Welcome. In this video, we'll take a look at section 5.3 with the double angle formulas. Let's take a look at those formulas first, and then we'll jump into a few examples. So the first double angle formula we have is for the sine function, sine 2a. We can represent as 2 times the sine of a times the cosine of a, where again a is some angle. So a is an angle. So this makes, I guess, the job of finding double angles or angles such as maybe 120 degrees, for instance, sine of 120 degrees. We could find this by using a double angle where we use the value of a to equal 60 degrees. And so since 120 is double that angle, we can simply use a 60-degree angle in the sine and cosine function to solve for that overall sine of 120. So let's take a look at how we can use that sine function right away with the first example, and then we'll look at the cosine representations in the next example. So we are given two items here. We have the sine of a is equal to 3/5, and we're given that the angle A terminates in quadrant 2. And we'd like to go out and find the double angle sine 2a. So let's consider first drawing a picture. So we'll draw our coordinate system here, and we'll draw up the angle that represents the sine of a equals 3/5 in the second quadrant. So that would mean that our terminal side of our angle is going to be of length 5. And so if this is A, angle A, in the second quadrant, we would have an opposite side of 3 and an adjacent side here. If we do a little bit of a Pythagorean theorem, we can recognize this as a 3, 4, 5 triangle. This would happen to be -4 as the adjacent side there. So we have a 3, 4, 5 triangle. And so let's take a look at the definition for sine 2a. Sine 2a is going to be 2 times the sine of a times the cosine of a. So all we need to figure out is what is the cosine of a, and we already know the sine of a. So we can actually use this right off the bat. So let's put it together. We have 2 times the sine of a for this angle is going to be 3/5. And the cosine of a, we can notice, is going to be the adjacent, which is -4, divided by the hypotenuse of 5. So that would happen to be -4/5. Now we can just simplify this result with a product. And so we'll have 2, 3, and 4 give us -24 over 5 times 5 is 25. So our double angle sine 2a is equal to the ratio -24/25. You'll notice that this is the only formula for sine 2a, but we have multiple formulas for sine of 2a, the cosine of 2a. So we'll take a look at those next. So we'll try to draw our attention back to our formulas and just take a peek at the cosine of 2a. Now the cosine of 2a can be represented in 3 different ways. Because of the Pythagorean theorem for sines and cosines, if we wanted to recall that, we know that the sine squared of a plus the cosine squared a is equal to 1. Because of this fact, we can represent the cosine 2a in a number of different fashions. So the first way we can do it is cosine squared a minus sine squared a. We could also use 2 cosine a squared a minus 1, and then 1 minus 2 sine squared a. Each of these three representations will give you the same result, so you can use any of the three. Sometimes you already know sine of a or cosine of a in your problem, and so there's a nice advantage to using either the second or the third representation depending on what type of information the problem gives. So let's consider the next problem, and we'll be using the cosine of 2a formula in the next step. All right, so let's consider the next example. This tells us if cosine of x equals 1 over the square root of 10, with x in the interval 3 pi over 2 to 2 pi, we want to find each of these double angles for cosine, sine, tangent, and cotangent. All right, so let's start with identifying at least what quadrant we're in. If I'm in this range right here from 3 pi over 2 to 2 pi, well, this would be equivalent to saying we are terminating in the fourth quadrant. So let's take a look at building a picture for this. I'm going from 3 pi over 2 to 2 pi. This is in the range of the fourth quadrant, bottom right. And I want to represent the cosine as the square root 1 over the square root of 10. So this would be 1 is going to be my adjacent side. Square root of 10 is my hypotenuse. And so I'd like to go out and solve for that opposite side. This angle here, wrapped around, is x. So this says cosine of a. We should probably change these two to x's here. So we'll have that updated in the notes. These should be x's. All right, so let's consider now finding the double angle. We do need that opposite side to figure that out. So if I wanted to find that opposite side, I know that the square root of 10, quantity squared, is equal to 1 squared, and then we'll call this side b. So b squared. We'll go out and solve for that opposite side. So we have 10 is equal to 1 plus b squared, or 9 is equal to b squared. That would make here b equal to plus or minus 3 when we take a square root. And based on where it's in our quadrant system, this is going into the fourth quadrant, so the opposite side here would be -3. So we're going to choose -3 here for our opposite side. All right, now that we have a triangle all worked out here, let's go and see how we can go out and solve the cosine 2x. So we'll start with a, cosine 2x. We can take a look. We already know what cosine of x is, so it'd be nice to actually use that information to our advantage. So if we take a look, the formula that uses the cosine is this one, 2 cosine squared a minus 1. So we'll use this just in terms of x to solve our problem. So 2 cosine squared x minus 1. Right, and again, we know what cosine is. So we can say that this is going to be 2 times cosine x quantity squared minus 1. So we'll work out this 2, and then we'll have 1 over 10 minus 1, or 2/10 minus 1. This looks like it'll be a negative number, which is negative 8 over 10, or we could represent that as negative 4 over 5. So we have that complete. Negative 4 over 5. Okay, the next one we have on our list, we've got the cosine 2x ready to go. We can go to the sine 2x. I'll do that part B. So sine 2x, we know, can be represented in only one way. That would happen to be 2 sine of x cosine of x. And so in this one, we actually have to go out and solve for sine of x. So let's take a look at what sine of x is going to be in our problem here. So if we take a look at the opposite side, we solve that as negative 3. And the hypotenuse is root of 10. So that's going to be my sine of x is negative 3 over the root of 10. And for right now, we don't have to necessarily rationalize that because we're going to be squaring this value. So we'll just leave it just like it is. So negative 3 over the root of 10. So we have the following. This is equal to 2 times negative 3 over the root of 10. And then the cosine we already solved for before was given to us as 1 over 10, the square root of 10 at least. There you go. So 1 over the square root of 10. So let's take the product here. We have 2 and negative 3 is negative 6. Divide by square root of 10 squared is going to be just positive 10. And that would give us negative 3 over 5. There's my sine 2x. The third item that I'm tasked to solve for is the tangent of 2x. One thing to remember, we don't need a special formula to solve for tangent of 2x. We can simply just take the ratios of the two that we just solved. So for part C, tangent of 2x is equivalent to sine of 2x divided by cosine of 2x. And so we have the cosine and the sine. So we have negative 3 over 5 and negative 4 over 5. We can flip and multiply here to simplify. And we'll have 5's cancel. And we'll just be left with positive 3 over 4. So there's our tangent 2x. And last but not least, we want to find our cotangent there. Part D is cotangent of 2x. And so we know the cotangent in part D, again, is the reciprocal of tangent. And so this will just be 4 over 3, the reciprocal function for tangent. That finishes up that problem with part D. All right, let's take a look at one more example. I'll let you guys take a look at this for just a little bit longer. And we'll go on to a third and final example with these double angles. The last example, we are starting with one of the reciprocal functions, and then we'd like to solve for a few more double angle functions. So let's take a look at the given information. We'll draw our picture and then work on our solutions. So we are given if cosecant of t is equal to the root of 5, with t being trapped between pi over 2 and pi, we want to find each of these double angles. So again, consider what quadrant are we in from pi over 2 to pi. Well, that considers the second quadrant. So this is, in other words, Q2. So let's draw our picture first. We're going to be in the second quadrant. Again, this is pi over 2 here in pi units. So we're right in the middle of quadrant 2. So if I have a cosecant of t equal to the root of 5, that would mean that my reciprocal function, which happens to be sine of t, is equal to 1 over the root of 5. So that's a nice bridge to make here, because we know a lot more about the sine function than we do about the cosecant, at least, when we go to graph this. So the sine of t we know is 1 over the square root of 5. So let's draw this in our quadrant. We're going to have a triangle with a hypotenuse of root 5. The opposite side is going to be 1. And so we need to work out the adjacent side here with the Pythagorean theorem yet again. So we'll call this the a side. And so we know that the square root of 5 quantity squared plus equals 1 squared plus a squared. So we have 5 on the left side, 1 plus a squared, or 4 equal to a squared. So therefore, a, if we take a square root of both sides, we'll have a equal to plus or minus 2. And in this context, a is going towards the left side of the y-axis, or the negative x-axis, excuse me, the negative x-axis. And so this x would have to be a length of negative 2. So watch out for the negative and positives here as we go for the Pythagorean theorem. So we have a triangle to work with now. And so it might be helpful here right off the bat to find our cosine of t, because we'll know we'll be using that. We know our sine of t is 1 over the root of 5, but our cosine of t here will be our adjacent. So that's negative 2 divided by the root of 5. And again, for right now, we'll just leave it just like that, because we know we're going to be using that cosine of t. All right, so let's take a look at using one of the other identities for our cosine of t. So the cosine of t, 2t. Another representation, let's take a look, that uses a sine function. We'll use this third representation next. So this will be 1 minus 2 sine squared a. We'll use that green one right there. Just to make sure that that one works, we have 1 minus 2 sine squared a. So we'll have in this 1 minus 2 sine squared of t. So we already know the sine function. So we have 1 minus 2 sine squared 1 over the root of 5 quantity squared. And then we'll follow this through with some arithmetic. 1 minus 2 times 1/5, or 1 minus 2/5, which is equal to 3/5. So there's our double angle for cosine. Part B, we're going to go find the sine of 2t. Sine of 2t. This has only one representation, 2 sine of t times the cosine of t. And we know the cosine and the sine function here, so we just have to use these in the equation. This is 2. The sine is going to be 1 over the root 5. And the cosine was negative 2 over root 5. So looking at the numerator here, we have 2, 1, and negative 2 gives us negative 4. And then root of 5 squared is going to be just 5. So that'll be negative 4 over 5. All right, and we have two other reciprocal functions to find here. And so we'll do part C next. Part C is for the secant of 2t. Well, remember the secant function is 1 over the cosine function. So that goes for the double angles as well. And so we can take the reciprocal of cosine 2t. That's going to be 5 over 3. And then finally, part D, the reciprocal function cosecant 2t. We'll finish up by taking the reciprocal of the sine 2t. And that will be negative 5 over 4. So that finishes up our list of double angles to find. Notice that we didn't have to know the value of angle t to solve each of these. We just needed to find their sine and their cosine. So I hope this is helpful with our double angle formulas. Feel free to watch this over again if you missed any steps. Hope to see you in the next video in section 5.4.